I'm Dave Breckell from One Electronics, and in today's panel tech talk we're going to talk about the use of filters with inverter drives. In our previous panel tech talks we've discussed the benefits of using an inverter, whether it's for better machine control, reduction in energy usage, reduction in cost, or in reduction in CO2 emissions. We've also discussed in the talk how an inverter drive operates using pulse width modulation. So essentially the inverter is creating a series of pulsed square waves using a transistor. This is seen as a sine wave by the motor, as it's simply a large coil on the rotor and the stator. This allows you to vary the amplitude and the frequency and control the speed of the motor. We've also discussed in a short tech talk how pulse width modulation can cause a phenomenon called EMC and an issue with harmonic distortion. And this is essentially where, because we have our nonlinear load switching very quickly, we can create a high frequency noise which basically rides on the carrier wave and can go back onto the main circuit that the drive is attached to, causing issues with other machines, comms, computer equipment, etc. So inverters are a very necessary tool, but they can cause a number of problems both on the input and the output side. The most significant problems on the input side of the inverter can be EMC issues, harmonics, commutation notches, inrush and peak currents, and low frequency interference. On the output side, issues and phenomena that can be experienced can be excessive dV/dt, peak and over voltages, parasitic earth currents, eddy current losses in the motor, displacement currents in the coils, bearing currents, and acoustic motor noise. Many of these problems, both on the input and the output side, can be fixed by the use of either one or a combination of filters. So on the drive input side, we can use harmonic filters, EMC filters, and regen filters, and we can use line reactors and commutation chokes. On the output side, we can use motor chokes, dV/dt filters, sinusoidal filters, and sinus plus filters. We're going to look specifically at the filter side today. Typically on the input side we would supply what's called an EMC filter. This is a key element in eliminating any mains-borne interference. So the EMC filter reduces the transfer of electromagnetic noise between the inverter and its power supply. Some inverters will have an EMC filter built in, whereas others will have an external unit. And sometimes you may use a combination for longer cable runs, for example, anything over 10 meters. How an EMC filter basically works is it utilizes a principle called a CR network. And inside there we have a resistor and a capacitor. In the case of high frequency noise or harmonic distortion, it can jump across a capacitor as if it was a dead short. So in the case of there being an EMC carrier noise running through the filter, the high frequency noise will jump across the capacitor to ground, and the low frequency, the power, will carry on to the motor. Another type of filter that you can have is what we call a dV/dt output filter. And this is what's used on the output to reduce some of the issues we spoke about affecting the motor itself. This has an advantage of reducing the dV/dt factor by 8 to 10 times. It can reduce the voltage, protects the motor coils, it improves the motor lifetime, it reduces audible noise from the motor running, and it can help lower the motor temperature. However, it is worth noting that these are all about protecting the motor and do little for the EMC environment. That is actually protected by the EMI input filter that we spoke about on the previous slide. A final type of output filter you can also add is what's called a sinus plus filter. This uses a modular sine wave filter. It's what we call an active filter. So essentially your noisy carrier-ridden harmonic signal will go into the filter, it will actively filter it out, and a pure sine wave will come out the other side. This allows the use of unlimited motor cables, and they can be unshielded. It eliminates any risk of bearing damage. It allows you to actually use a smaller EMC input filter on the other side of the drive, and as I mentioned before, an unlimited cable length. This does a lot for improving the overall EMC environment. Where these are used are essentially where no cable shields are possible. So it could be something like the chemical industry, for example, where you have intrinsically safe motors, cranes, or even in situations where you want to retrofit a drive into an existing installation, where you need to use the existing old cabling and motors. Perhaps the cabling is buried underground. Further uses for these, because of the extreme length that you can have in terms of cable, is things like tunnels and mining applications, or for high-speed motors, mandrels, etc. there as well. One of the issues that can occur, of course, and when we looked at the CR network before, is that the high-frequency noise is jumping across the capacitor in the filter and going down to earth. This can cause issues in terms of tripping out things like RCDs that you may use for protection in the circuits. And we'll discuss the way around this and the special type of protection that you have to use in our upcoming panel talk on inverter protection. And also another important factor is to look at how we actually mount the inverter in the panel itself and the cabling attached to it, where it's mounted and glanded, and we'll also discuss that in an upcoming talk. If you'd like to know more about Omron, please visit us at our website, which is industrial.omron.eu, and I look forward to speaking to you again. Thank you.